Hello viewers, in today's session we are going to discuss another important and very conceptual problem from definite integrals, right? So here in this class we are going to solve this integral where we have the limits from minus pi to 2 pi, and our integrand is tan inverse x plus tan inverse 1 over x, right? So this integral is a very interesting integral, and here we'll solve this integral by using the properties of inverse trigonometric functions. So let us first see the property of inverse trigonometric functions. Right now, see, we know that the value of tan inverse theta plus tan inverse 1 over theta is equal to pi over 2 when theta is greater than 0, right? So tan inverse theta plus tan inverse 1 over theta is equal to pi over 2 whenever this theta is greater than 0 or it is positive, right? And tan inverse theta plus tan inverse 1 over theta is equal to minus pi by 2 whenever theta is less than 0. So this property is the key property here to find out the value of this integral. So let us call this integral as I, right? So here we are not going to prove this property, rather we'll use directly this property to find out the value of this integral. So here the limits of integration are from minus pi to 2 pi, right? So let us break this integral at the point 0, right? So it means that all the values of x which lie towards the left of 0 are negative, and all the values of x which lie towards the right of x is equal to 0 are positive, right? So here we have x is equal to 0. So let us split this integral at this point. So we can now write minus pi to 0, and we have tan inverse x plus tan inverse 1 over x dx, and then we have the integral from 0 to 2 pi tan inverse x plus tan inverse 1 over x dx, right? So the purpose of splitting this integral into two parts is that when x belongs to this interval, that is from minus pi to 0, then the value of this expression is equal to minus pi by 2, because all the values of x which belongs to the interval minus pi to 0 are all less than 0, right? It means all the values of x are negative, right? And similarly, when we have x belonging to this interval, that is 0 to 2 pi, then the value of this expression is equal to pi by 2, that is positive pi by 2, because here these x are all positive in the interval 0 to 2 pi, and here all the values of x are negative when x belongs to minus pi to 0. So now I can be written as minus pi to 0, and tan inverse x plus tan inverse 1 over x is equal to minus pi by 2. And here we have dx, and in the second integral we have 0 to 2 pi, and here we have plus pi by 2 dx. Right? So tan inverse x plus tan inverse 1 over x is equal to pi by 2, because here all the x are less than 0 and here all the x are greater than 0. So now we can write minus pi by 2 and integral from minus pi to 0 dx, and then here we have pi by 2 0 to 2 pi, and here we have pi by 2, here we have simply dx, right? So now we have minus pi by 2 and integral dx is simply x, and here we have x and limit of integration are from minus pi to 0, and here we have pi by 2 and integral dx is simply x and limits of integration are from 0 to 2 pi. So now we can write minus pi by 2, and we can now substitute the limits and we'll take the difference. So we have 0 minus minus pi, and here we have pi by 2 and 2 pi minus 0, right? So now I is equal to minus pi by 2, here we have 0 plus pi, and here we have pi by 2 times 2 pi. So this is minus pi by 2 times pi is minus pi square over 2, and this is 2 and 2 get cancelled, so we are left with pi square, right? So now we have minus pi square plus 2 pi square over 2. So 2 pi square minus pi square is pi square, and here we have 2, right? So the value of this integral I is equal to pi square over 2, and we can see that how easily we can evaluate this integral by using this important property of inverse trigonometric functions connecting tan inverse theta and tan inverse 1 over theta.